Hello, everybody. Welcome to Open Source Antibiotics on Friday, November the 27th. I'll just share the correct thing and we can get started. Hopefully that is now the right thing. Everyone can see the right window, hopefully.
Yep.
All right, good. So we will do the chemistry update in a minute because that will cover the most recent targets, I think, which we're looking at, because we're still, I guess we were talking about this the other day, we're still at the point where we don't yet have the mechanism of action stuff, so we're still waiting, and we don't yet have the cytotoxicity data, if I'm still right in saying that, I think. So I don't have either of those two things. So we're still at the moment, making compounds that plug SAR holes, essentially. And that's fine. So we just need to get those made and then evaluated. I'm finding out, I'm trying to find out if we have the possibility of doing another round of potency evaluation before Christmas. So it's on me to ask our colleague Paul Stapleton about whether we can do that, which will be good because we've been making some more compounds, right? And we also have some coming in, hopefully, from Laurie. So important to get some more data done on that, which is good. But I think, we've got lots of nice ideas about compound design, and we can pursue those once we have some more data points, I think.
Yeah, because right now we're trying to plug holes. And that's what I've been doing, at least, with what I've been proposing, is just plugging holes, but
I mean, that's all we can do at the moment because we're not guided by something else. Dana, I don't know if you have been in touch with Laurie recently. There were just two things that came up. One was the shipment of compounds, and one was digging up things like tox data on their compounds.
Yes. So, good question. I have been in touch with her, but not about this. I can ask her about that. I think, and I'll check. I think when she shipped the compounds last time, she also sent me a spreadsheet with their data. So I'll just double check that that's been uploaded.
Great, because I think the 5 she was going to send, they've not been sent yet, right? I don't think. Have they?
No, I don't think so.
Okay. All right, great. So we just need to ping her about those two things. That's fine. Okay, that's fine. I think everything else is as it was last week. Do you want to do some chemistry just to bring us up to speed with what we're looking at?
Yeah.
It's been purifications this week, right?
Mostly, yeah. Do you want to go first, Dana?
Yeah, that's good.
Sure. So the nitrogen linked, so I'm looking at the top row. I've tried 2 different sets of conditions for that. I'm just getting starting material. I am going to put a Buchwald in the microwave. I've searched the literature, so I found a prep that's been done on sort of similar substrates, so hopefully that will work. Then the core compounds with the tazol substituent, the methoxy core, I think I need to repeat that reaction because after purification, I've still not got it clean and there's just not enough material to repurify. The chloro one looks nice, so that's done. Then the 2 bottom ones, the benzofuran on the DNDi core is clean, so that one's good. The indole there's still a little bit of something in the NMR, so I'm going to try and triturate it using Alvaro's mixture and see if that helps.
Do you think you have that crude?
Which one? Sorry.
1512.
Yes. Yeah. There's only a little bit of just some peaks in the baseline of the aromatic region, but otherwise the NMR looks good.
Okay.
Yeah.
It's funny about the top row, why that's being tricky. And I mean, you're sure it's starting material. It's not like the bromines come off or something.
No, I checked it by LCMS and
Okay.
I see the bromine splitting, so it's there, definitely that. It's
Okay,
just,
I mean,
it just doesn't really look like it's doing anything besides sitting in solution and stirring. So
right, wow.
yeah.
Okay, yeah, I mean, you just got to push it, I suppose.
Mm-hmm.
And we want the aniline, right? We're not interested in like benzylamine, because that's more nucleophilic, obviously.
I think there
was an example of a
there might be an
benzyl in there.
example. Yeah, I can try that as well.
Yeah.
It wouldn't hurt to try, and that should probably work fine using sodium hydride.
That's the proof in the pudding.
Mm.
I mean, if it's not a waste of time, then it could be, I mean, SAR wise, then it could be worth doing.
I'll just double check that one was active, but I think it might have been.
Okay. Great. All right, but
The
I mean,
alternative would be to use something like silver oxide as the base,
right.
which would coordinate to the bromine as well.
Yeah, or I guess we could look at synthesizing it using the one pot procedure, which is how all those DNDi compounds were made.
Yeah.
Isonitride, it's supposedly quite unstable, so that's going to require a lot of searching.
Mm.
Sorry, for the one pot is the second bit of the one pot? Is it that reaction, or is it a separate approach, completely separate approach? You mean the DNDi approach is a separate retrosynthetic approach, right?
Yes, yeah. So you don't start with that brominated core. You start from the pyridine. I think that's an aldehyde, then the aminopyridine, and then your isocyanide.
Yeah, I think using a more nucleophilic amine, using the silver idea, using microwave, if they give you nothing much or it's a hassle, then it could be a time to pull the plug and try the other approach. Yeah.
Mm-hmm.
Probably a thiol linker in that position wouldn't be too terrible to make, I can imagine. Parathiocresol, sodium hydride, just repeat the top one.
Yeah, I can look into synthesis of that, but I don't think that's a bad idea.
That will be a lot hotter than the nitrogen will be in terms of nucleophilicity.
Mm.
Great.
Right, and then so for my stuff, so these 5 compounds are done, about 20 megs of each. So this last one with the 2-methyl, I got about like 20% of the debrominated core and only 6% of this, which is like 3 megs. So I'm going to repeat it.
Steric blocking going on with that method.
Yeah. So I'm going to repeat that on a larger scale. But yeah, from the NMR, I can see that this methyl group is splitting the protons on that methylene. So yeah, there's some interaction going on there.
But so the MIGs you've got would be enough for Paul's assay?
Yeah, but it's not entirely the cleanest.
Right. Okay.
So yeah, I've put it on again anyway. And then these other 2 reactions are just from doing some literature searching. So I was looking at this compound with the nitrogen removed from this position, and there's an old paper from like 1979 that does this reaction. It's also in German, so but yeah, they had that to make substituted compounds with that core. Like the procedure seems easy enough, but I don't know. And then
can we get that with the thing installed, the pyridine?
Yeah, so I've looked at this substrate with the pyridine and this green ring, and it's not cheap. And going from the compound without the bromine is also not too easy, or like expensive. But yeah, we just have to be going back in synthetic steps to make the relevant pyridine compound for that. And then the last one is just a book fold that I found this morning. I don't know if Dana saw this, but it's on, somewhat similar core. So, maybe that's worth a try as well.
Yeah, can try that.
That's nice. Ed, for the middle line, the search you've done, I mean, I guess we want the blue and the green rings.
Yeah.
And we want something on the nitrogen.
Yeah.
I would guess, but is that so? If you just search on that core where the nitrogen has a carbon attached to it, is that all you get?
Like without the fused rings?
Yeah.
I've not done that search, no.
Okay, because I mean, we could tolerate, some variation there, but the rest of it, the pyrrole with the two aromatics, I think is necessary.
Yeah.
Yeah. And not necessarily specifying it's a phenyl, obviously, because it could be a pyridine.
Yeah.
So just be careful of your search terms, I suppose.
Yeah.
Because I mean it's a nice reaction. It's just fiddly to have to, roughly fine to have to make the starting materials. It's just a bit fiddly.
Yeah.
Nice to avoid that.
Actually, I think I have the. Yeah, so this is the paper. Yeah, so that was the scope.
Yeah, so just get rid of the ring maybe, because that's their focus here.
Yeah.
Does it have synthetic procedure detail?
In German, yeah.
We can deal with that.
Yeah, I mean, I've translated it. So it's just in solvent. Yeah, I mean, it seems pretty straightforward.
Okay, that's good. But yeah, just try another search there, because it would be, it's one of those things where it's a lot of synthetic effort just to get a molecule with a 1 atom difference, but it could be worth it. Okay, that's good. Great. That's nice. And then, so yeah, the stuff by Haifa. So this is really good. We have now done the paperwork and we are good to go. So we have now shipped the molecule to Haifa, and I understand it's arrived.
Yeah.
Right. Yeah. So we're good to go, and Haifa are happy for me to say that we're doing this work, which is awesome. So this is a very nice in-kind contribution from them to the project to help us try and understand what's going on with these molecules. So they are running this through. They have a collection of CYP enzymes. So it's these sort of polycyps kit that they've got, which they sell, and they're going to run it in situ for us. And I think a human liver S9 enzyme in oxidation mode. So this is kind of one of the things that they offer as a service, and they're doing it for us pro bono because it's an open project. And they are also, I think, going to try and run, if they can, some glucuronidation stuff to see if that is also a way in which the molecule is metabolized. And they, again, if they have capacity, they have a microbial panel, which they might run this thing against. So there's a bunch of stuff they can do. The deal here, and again, it does depend on how it goes and how difficult things are. And they've been upfront about that. There's not infinite resources here. The deal is that if they get something simple as a transformation of the molecule into sort of one other thing, that they will, try and figure out what that thing is, obviously, and they are happy to try and do some scale-up work, to do some preparation of that molecule so that we can more accurately characterize it. So likely that the screen stuff will happen in about a week and a bit's time. And then maybe after Christmas will be any kind of scale-up. If there is scale-up to be done, Ed may have to make more of that molecule, and we've already spoken about that because they need quite a bit of molecule for that. Again, it depends, you know, what kind of reaction we see. But this is really awesome. So it could be a way of us getting some more information about what exactly happens to this molecule. So we could do some metabolic ID, which is great. So we're leaving it in their hands, and we'll get updates, and I'm allowed to share those updates. So they've been really good about being able to share things, which is very nice. So I'm glad that's happening. It was just a paperwork delay. It was nothing difficult about it. It was just a paperwork delay. And then all the other stuff. So we remember from last week the other things that we were talking about crowdsourcing and other things. I haven't had a chance to do anything on me. It's been a busy teaching week for me, but I haven't had a chance to do anything on this. But I will. And there was the other thing we were just talking about for Lab Archives molecule sketching facility. Have you guys been able to assess this?
Yeah. So I don't know. I'm not too convinced about it, really.
You draw a molecule.
Yeah. So let me.
It goes on the page. Oh, shall I get rid of mine?
Oh yeah. Right. So. Oh, I should say. So what I've normally been doing is putting strings at the end of the page. So for this one, I got rid of that and replaced it with the chemical sketching thing.
So this is a widget.
Yeah, so it's one of the widgets.
Yeah.
Chemical sketching thing. So searching by smiles, like you draw it in ChemDraw and put that in here. Well, I guess any string, it doesn't give you the result. The only way to get the result is to draw it using this, and then it'll show up.
Right.
But it looks like it's using like the different smile strings. I don't know, is that canonical or non-canonical? So that's the one. This is the smile string you get.
So it's just doing a text match rather than a structure-based match.
Yeah. So yeah, I mean, this is the string that you get from ChemDraw, and it doesn't give you it. But then if you go into the structure and then use that, it'll change it to this string, which does give you it. So
searching within the widget works.
Yeah.
So using their search function works.
Yeah, by drawing it, that works.
Sorry, Chris, why is that?
Because there you've got the smile string, you have all of the aromatic rings or the atoms as lowercase c, which is an aromatic atom. When you draw it in ChemDraw and you do the Kekulé form, you have effectively a ring containing all aliphatic carbons with double bonds between them.
So this is one of the reasons why we, I mean, Chris Southern always tells us to use more than one string to make sure we pick up.
Yeah. So I mean, in this thing, it only takes smiles, so you can't put in inchy or inchy key.
Right.
Inchy would be much better, wouldn't it?
Yeah.
And if you search the notebook with the inchy, I'm guessing nothing comes up.
No.
Because it doesn't do that.
Yeah.
So that's a feature request.
Yeah.
And what about using their smiles term?
Yeah.
Googling that.
Not really. Yeah, because I think it's. Let me just try that again.
So that's November 24th.
See that? Well, sorry. Well.
Yeah, I mean, none of that's mine. Yeah, doesn't look like it's showing up.
Because it should, right? I mean, if it's if it is if it's adding it to the page when you draw it, it should be there to be found. So that I guess I was expecting that to be visible because it should be on the page as metadata.
Yeah. So, I mean, I did search Inchy key for it and it comes up, but I think this is from before I removed my, smiles thingy.
Can you not have both the Inchy and the smiles then
In which?
in your notebook?
Yeah, so I normally did, but then with this tool, it doesn't.
Well, that's what I meant, sorry. Yeah.
Yeah.
In the spreadsheet of all molecules, we have smiles, and I guess we just have one of these, not both, right?
We have smiles and Inchy key, I think.
I mean, we have one smile string.
Yeah.
A smile string is not unique, you see, because there's many ways you could draw it. So if you're just doing a text match, you risk not finding it.
I mean, we need this fixed, really, and I'm not sure what the best solution is. The thing we're trying to fix is making sure that we can search from the outside of the lab notebook and find molecules that we're working on without having to paste in the strings. That's the solution that we want. And if the strings appear on the page, then we're set, and we've shown that. But at the moment, there's a break between drawing something with the widget and the relevant metadata appearing. So I think it's the big thing is working in the sense that you can Google these pages, but the small thing is not working in that the widget isn't displaying the strings properly. So we need that fixed. It's a feature request. Ed, I'm sorry, I'm going to have to ask you to write this up in a couple of paragraphs. Because I'm going to have to forward this to Lab Archives and ask them if they can help us with it. So what works and what doesn't.
Yeah.
Thank you. That's really good that it's been tried. Yeah, it would make a big difference if we could do that. And then, Chris, I remember you submitted, I think, our page.
Yeah, they did say it would take a week to index, so it hopefully it would be there next week.
Okay. Fine. Okay, great. Thank you. And I think that in terms of the other action items, I think we're all set. So yeah, in that case we wait for mechanism of action data and tox data. Those are the two big things, and we keep plugging away at those syntheses, I think. Yeah. All right. Was there anything else anyone wanted to talk about? Hi, Ben. We're kind of basically finishing up, I think. We also.
Hey, sorry, I was on mute.
No worries.
Yeah, no, I just came out of a meeting early, so I didn't think I was going to make it, but I thought I'd drop in and say hello. Hello.
Hi. We were just saying we're waiting for the tox data, and we're waiting for mechanism of action data, and some comments are coming in from Laurie at some point, and
Are those ones linked to the DMDI project that we're working on with her same but with the fully aromatic core, right?
Yeah, very similar compound. So we were gonna get that.
So some of the ones that I sent through in the initial suite, there were a couple of actives in there, right?
Oh yeah.
Okay, cool. Good.
Yeah. Sorry, do you want me to share that in case you?
No, it's okay. I mean, I'll maybe I'll do if I have time when I join next week. Just so you know, so some of those I've just had the article we wrote on that series released from ISS was accepted today, so it should be published pretty soon once the open access payment is made. So there'll be a little bit of data in there on that and all of the write-ups on experimental and whatnot. So
great.
If you're interested.
That's brilliant.
If our MRSA compounds would have any effect on leishmaniasis, they're very similar in core structure. Might be something worth trying.
Sorry, Anthony, I didn't hear the first part of what you said.
I mean, sort of cross-pollination where you send us some compounds and our team will send you.
Guys, if there's some way that you can get the saturated, like the 5,5 where it's hemi-saturated, if we can get a couple of those to test, that would be cool. I'm trying to think of the best way of doing it. I'd probably send it to Laurie. I don't know. It depends where they are. Where are the molecules?
You mean ours?
Yeah, the ones you found as hits. We can test a couple of those in least and Shagas just to see if we can get it shipped across to somewhere.
Yeah, sure.
Yeah, it just, I mean, no pressure. If there are a couple available, that could be interesting.
Yeah, that's a good idea. Yeah, absolutely. Always happy to do that kind of thing.
Might be best.
And we're getting metabolic ID on our lead compound from Haifa Biosciences. You may know them, that do a bunch of metabolic stuff in the UK.
Yeah. Okay.
All right, good. Well, nice to see everyone briefly.
Okay.
See you next time around.
Yeah. Bye then.